Okay, let us now try to understand the structures that we need for building a singly linked list. You can see I have declared two structures there for implementing a singly linked list. Structure node contains an integer data and a next pointer within itself. For your practical need, the data within the structure node can be anything else, such as an object of employee or student, or maybe a character array to hold some name. That really doesn't matter if we try to understand how we could build a linked list, as the data part is not going to affect in any way for linked list operations. See the declaration of node pointer carefully. That's important. Next is the pointer to node. That means it is meant to be there for keeping the address of a node object. That is the same type of object within which it is declared. This could be confusing at the beginning to some of you, but it's quite intuitive. Try to remember the fact that each node will hold the address of the immediate next node, and the next node is an object of same type, that is the structure node within which you need to declare the node pointer. So the pointer has to be struct node pointer type. You can see that the next pointer of the current node is going to hold the address 500 of the next node, which is again a node object. So this next pointer has to be declared as a node pointer. So that's going to be the self-referential pointer type. That means a pointer which is going to point to an object of self type. The structure linked list is a template for linked list object. A singly linked list will need a head and tail pointers for holding the address of first and the last node respectively. So linked list structure contains two node pointers, head and tail. Apart from these two pointers, I have also declared an integer node count there, just to have an account of number of nodes in the linked list. When we'll be adding a new node, we'll increment the node count, and when we'll delete a node from the linked list, we'll decrement it. So at any point of time, we can get the number of nodes in the linked list in this node count variable. And that's going to be helpful for building some of the operations. So when we'll need a linked list, we'll create the object of linked list structure there in our program, and for each node in the linked list, we'll create the object of struct node. Let's now move ahead to the next lecture, where we will see how we can write different operations for singly linked list. Stay tuned.